what were you titrating in lab yesterday? What acid did you have? You had HNO3. Okay. And what did you titrate it with? NaOH. Okay. So let's start out by writing the balanced equation. What's the first thing that's going to be formed? Water. And the second thing? Sodium nitrate. Okay. Now, is this the best way to look at the reaction? Okay. Perhaps not. It gets us started, but maybe an ionic or a net ionic would shed a little bit more light on what's going on, right? Okay, so tell me what to do with HNO3. Do I keep it together or do I break it apart? Why do I break it apart? Okay, nitrates are soluble, but this is an acid. It's a strong acid. How do you know your list of acids? Okay, how many have memorized their strong acids? Okay. If you looked on your review sheet, do you have to memorize them by tomorrow? Yes. Do you know where to find them? Page 54 of your Ultimate Chemical Equations Handbook. Okay? Page 54. You could also just Google strong acids, and that would work as well. It's okay. All right, so HNO3 is strong, and therefore we break it up. H plus and NO3 minus. Okay? Tell me about sodium hydroxide.
Strong base.
It's a strong base. We break that up. And besides being a strong base, it is an ionic compound, which is a salt, and it has a 1A in it. So you can think of it either way. Okay? Tell me about water. It stays together. It is a liquid. It's not a strong acid. It is not an ionic compound, so we leave it together. And you can write it as H2O or HOH. It doesn't matter, whichever way works for you. Tell me about sodium nitrate. Definitely breaks up. It's soluble because it's a 1A, and why else? And it's a nitrate. Okay, cool. All right, so this is our molecular equation. This is our ionic equation. And now, what will our net ionic equation look like? H plus and OH minus makes water. And that's it. That is the essence of what is changing in our reaction. Okay? Let's first kind of focus on the calculations. And I want to make sure everybody was reading their burette correctly. Okay? So remember, your burette, when it's full, actually reads 0. That means 0 has been delivered. But most of us, when you walked up to your burette, it wasn't on 0, was it? Okay? It was on a different number. Let's say it was on 5.37. Okay? Don't do anything fancy. Some people were like subtracting this from 50 and then recording that number. No, 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 no. Just record your initial volume, 5.37 mils. Okay? That 5.37 has been delivered to something. Maybe to someone's experiment in 4th period, maybe to your waste beaker, right? Maybe to the sink, whatever. But you've already drained 5.37 out of there, okay? Then you put your flask in there, you start titrating, and let's say it turns pink at 20.37. This is the number you record, okay? Notice, did I record 15 anywhere? No, because 15 really isn't data. That is the calculation. Okay? All right. But given this information, the first thing we're going to do is we are going to take our final volume minus our initial volume, and we will get the volume used. And notice I'm using easy numbers. Tomorrow on the test, you won't be able to use a calculator for multiple choice. You will for free response. So if I made this multiple choice, I'd have to rig it to where you had easy numbers. Okay? Yeah, got to do that. That's kind of a promise. Okay, so I have my milliliters of base. What would be the easiest way to solve for the molarity of this problem, of this acid? I could convert that to liters. What would be even easier? Someone said M1V1 equals M2V2, or let's adapt it, MA VA equals MB VB. Now you know I don't love this equation because it doesn't work all the time, but when does it work just fine for? A 1-to-1 ratio. And if what we have is a 1-to-1 ratio, this is the quickest. And time is pretty valuable on the AP test, right? Okay, so the molarity of the acid, that's what we don't know. The volume of the acid, how much did we use? We used 10 mils. Did it matter that we used 10 mils? Could we have used 9? Yeah, we could have used any amount we wanted as long as we recorded it, right? Okay, molarity of the base, what do we have? 0.1. That was on the bottle, okay? On the bottle of sodium hydroxide, it told you the molarity. You have to know that. So here's 0.1 molar. And the volume was the difference, 15 mils. Okay? This will be even easier than having to convert to liters, right? When you do it this way, you can actually leave it in milliliters. So it just makes everything simpler. Okay, so our overall calculation ends up being 0.1 times 15 over 10. Okay, you should be able to do this without a calculator. Let's work through. What is 0.1 times 15? 1.5, right? Okay, and if you need to think of it this way, guys, is multiplying by 1 easy? Yeah, anything multiplied by 1 is that same number. If you need to turn 0.1 into 1, how many times do you have to move the decimal? 1 time. So how many times would I have to move the decimal here? 1 time. So 0.1 times 15 is 1.5. Now we're going to have to divide that by 10. Again, some of you can do this easy, but some of you how many of you kind of freak out a little bit when you have to do this in your head? And you're just like, oh, oh, oh. Okay, so here's the quick way. Ready? Just like we can multiply by 1 and it's easy, is it easy to divide by 1? Yes. Yeah, okay. Maruna, how can I turn 10 into 1? What would I do to my decimal? I'll move it over 1. So what do I have to do over here? Move it over 1. So guess what my answer is? 0.15. Isn't that a nice tool? Okay, so use those simple tricks so that you don't kind of freak out on those, okay? All right, so 0.15 molar, and we're done. Isn't that nice? Okay, all right. Now, does this work all the time? No. If it was a 2-to-1 ratio, it'd be different, wouldn't it? Okay, so let me show you the other way. We could actually start with the 15 milliliters of NaOH, and here, when we do stoichiometry, what's our first job with our given amount? What do we convert it to? Moles. No matter what. If we have grams, we convert to moles. If we have milliliters, we find a way to convert it to moles. If we have particles, we convert to moles. So how can we convert milliliters of a solution to moles? Using molarity, okay? Here's a reminder. 0.1 molar means 0.1 mole per 1 liter, right? So watch what we'll do. Or 0.1 moles per 1,000 milliliters, right? Is everybody with me? So from this bridge, I have converted from milliliters to moles. And if you notice what I've done, haven't I just taken molarity and multiplied it by volume? Right? Doesn't that work? Okay. Now I'm going to keep going. Every 1 mole of NaOH needs how many moles of nitric acid? 1. Now, at this point, I'll stop my bridge. I've got 15 multiplied by 0.1 divided by 1,000. Let me do this without a calculator. What's 15 times 0.1? 1.5, right? If we have to move this over to make 1, then we'll move, does that work? Oh, that doesn't work. Oh, yeah, we did. Okay, so we move this over, we move this over, we get 1.5, right? So we have 1.5, 15 times 0.1. It's really 15 times 1/10, right? Okay? And then we're going to divide by 1,000. Is this number going to be bigger or smaller if we divide by 1,000? Smaller. So if we move this over 3 times, then we have to move this over 3 times. 1, 2, 3. So we're going to have 0.0015 moles. Is everybody with me? Okay. So 0.0015 moles. Remember, I want molarity. What is molarity? Moles per liters. So we have our 0.0015 moles over our liters. What is 10 milliliters converted to liters? 0.01. And so again, let's do our decimal trick. If we have to move this over 2 to get 1, then don't we have to move this over 2? I can't hear you. 10 milliliters. There's 1,000 milliliters in 1 liter. So 10 divided by 1,000 is 0.01. Or you just move the decimal over 3. Right? That's the quick way to convert. Okay, so do you see how you get the same answer both ways? Okay? Now this, don't you think this took a lot longer than MAVA? Okay, but if our reaction had been nitric acid and calcium hydroxide, what would our balancing have been? It would have been one of these needs how many? 2 of these. And so how would this have changed if this was calcium hydroxide? What would have changed about this bridge? Where would the 2 go? Would it go with the calcium hydroxide? No, it would go with the HNO3. And so you would end up with 0.3 molar. You guys see that? So that's why it's important to kind of know that process as well. Okay? I'll go ahead and stop.